So we generally talked about friction in the last lecture. Now we're going to analyze motion with friction. So most frictional forces are complex because they are affected by a number of factors, such as the nature of the materials involved and the size, shape, speed the object's moving. Some problems involving friction bring together many concepts, including velocity, acceleration, forces, free body diagrams, Newton's laws of motion, and weight. However, when we're analyzing these, there are some common mistakes you can avoid. The first is to include a free body diagram. So failure to include a free body diagram sometimes causes students to misinterpret some of the forces that are involved and not include all of them. Sometimes students account for too many forces. We see this occasionally when there's something that's stopping due to friction. The idea of, say, somebody doing a baseball slide into a home plate, there is no applied force at that point. The only force is now the frictional force slowing the person down. Just because something is moving doesn't mean a force has been applied. And then the last one here says not including directions in their solutions. So in a case where a question doesn't state a direction, and the motion is one-dimensional, it's okay to not include directions, but you do have to be consistent. If you consider going forward as positive, then you have to make all of your forward-moving objects be have a positive force on them, but if they're going backward, they must be negative. So the force of friction is actually dependent on the normal force that an object experiences, and it is actually a component of that force. We take that normal force, we multiply it by a ratio known as the coefficient of friction. And that coefficient of friction, it is a ratio of forces, so it is a unitless measure, but it is between 0 and 1, usually not including 0. So the coefficient of friction is some percentage of the amount of the normal force that we experience. So the coefficient of friction is a ratio of force. It's the force of friction divided by the normal force. Quite often you'll just have the coefficient of friction value as a decimal number, and you'll need to apply it using the F equals mu Fn, and that's that symbol there you're seeing is mu. When the coefficient of friction is 0, we have a frictionless situation. That rarely happens, but in physics problems, to make them easier, we quite often consider that mu is 0. So when no friction occurs, then it gets a bit easier to analyze a problem. But for any problems that don't state that it's frictionless, you have to assume that there is friction involved. Now, we talked about kinetic friction and static friction. And it's important to understand that the static friction, which is mu subscript s, is always greater than the kinetic friction coefficient, which is mu subscript k. So this is worth copying down here. The ratio of kinetic friction to normal force is your kinetic friction coefficient, and the ratio of the static friction to the normal force is your static friction coefficient. Your static friction coefficient is always greater than the kinetic friction coefficient, or they're equal to each other, and that means that the force of static friction is equal to or greater than the force of kinetic friction. So here we're given the coefficient of kinetic friction for asphalt and concrete, and the coefficient changes depending on the conditions of the road. So When we have dry conditions, asphalt is 1.07, and when we have wet conditions, the asphalt falls down to 0.95. Because we want to have a fair amount of friction, asphalt would be better in dry conditions than concrete because it has a higher coefficient of friction. But in wet conditions, concrete would be better because it has the higher coefficient of friction in wet conditions over the asphalt coefficient of kinetic friction. So here's a problem. It says it takes 58 newtons of horizontal force to get a 22 kilogram leather suitcase just starting to move across the floor. So what is our coefficient of static friction? Well, if it takes 59 newtons to get something that weighs 22 kilograms, that would be 22, and we'd have to divide by 9.8. We get 0.27. So it's 59 newtons divided by the force of gravity, which is 22 times 9.8. So we get 0.27 newtons. Sorry, 0.27 is our static coefficient of friction. There is no unit. Same idea. If it takes 54 newtons to keep the suitcase moving, what is the kinetic coefficient of friction? So here, if it takes 54 newtons to keep it moving, then what was the mass of this again? That doesn't show there. It's a 22 kilogram suitcase. So we have to divide by 22 and 9.8 again, and we get 0.25. So the kinetic coefficient of friction is less. This question says we have a hockey player glides across the ice on skates with steel blades with a very low 0.010 coefficient of kinetic friction. What is the force of friction acting on the skater? So in this case, the force of gravity acting on the skater is their mass, 73 times 9.8. So 73 times 9.8 is the Fg, which is equal to their Fn in this case. So we multiply that by 0.010, and we have 7.154. And we have to round to two significant digits, so we get 7.2. A worker of a moving company places a 252 kilogram trunk on a piece of carpeting and slides it across the floor at a constant velocity by exerting a horizontal force of 425 newtons on the trunk. What is the coefficient of kinetic friction? So for this problem, we have 425 newtons divided by 252 divided by 9.8, and I'm going to include a 1. The reason why is because we have 3 significant digits in our givens. 252 has 3 significant digits, 425 has 3 significant digits, so we should also have 3 significant digits in for any constants. And 9.8, or G with 3 significant digits, is 9.81. This gives us 0.1719, which rounding to 3 significant digits would be 0.172. So that's what we should have for this value for the kinetic coefficient of friction. The second part of this question states, what happens to the coefficient of kinetic friction if another 56 kilogram trunk is placed on top? Nothing, because the two objects in contact have not changed. So that's something else to consider. And number 5, This one here says we have a hockey puck. It slides on the ice at 19 meters per second east. It hits a rough patch of ice that's 5.1 meters across. So let's see what's happening to this hockey puck, and this time we'll turn our camera on. So what's happening to this hockey puck? Well, in the free body diagram, the hockey puck is moving. But let's say its motion is to the right. However, it's only experiencing a frictional force backwards. And if that's the case, then its F net is equal to its FF. And the question, it says to draw the free body diagram, but also we're asked to calculate the kinetic friction acting on the puck. Well, if it's 0.47 is the coefficient of kinetic friction, then FF is equal to mu Fn. And in this case, Fn is equal to Fg. So FF is equal to mu mg. So we have 0.47, not 27. M is 0.17. G is 9.8. So we end up with 0.47 times 0.17 times 9.8. Our force of friction is 0.78. I'm going to write down the full value, and then I'm going to write down just the value that is with significant digits, because this is my actual, this is my reported value. So as I'm reporting a value, I have to report it with the significant digits, but my actual, I can keep some extra digits in that, because the next part of this question is going to ask, let's see what it says here, determine the puck's acceleration through the rough ice. And I could use that actual value to help solve this. So the acceleration is F net equals ma, and that is equal to FF. A equals FF over m. And I should now consider this is actually a negative force, so it's going the opposite direction. So I'm going to write negative 0.78302. Since it's a terminating decimal, I'll write the full value, divided by 0.17. And when I use my calculator, I can now divide this by 0.17, and I get 4.6. A equals negative 4.6 meters per second squared. And now the last part of this, here it says that calculate the puck's velocity as it leaves the rough ice and returns to the smooth ice. Well, let's go back and just technically this was not 0 or 4.6, but it's actually 4.606. And when we're considering this, we have to look at the Newtonian equations we have, and we have a VI, we have an acceleration, we need to find the VF, and we have a D. So we would use this equation, VF squared equals VI squared minus 2AD, or rather plus 2AD, but that's going to be minus because we're slowing down. So VF squared equals, in this case we have 19 squared plus 2 minus 4.606. The rough patch is 5.1 meters. So VF is going to be the square root of all of this. I'll just write it again. I like to do all my calculations at once. So 19, let me remember this value so I can recall it again later. 19 squared plus 2 times my recalled value as a negative. I don't see a way to turn it into a negative here, so I'm just going to multiply it by -1 times 5.1. That's what I have underneath my square root, and when I find the square root I get 17.7, or 18 meters per second. And that would still be going to the east. I might as well write that down. So that's how we would solve that. There is another thing to consider here. When we're talking about force of friction, we haven't seen an example yet, but you might see one where the force of the normal force is not exactly the same as the force of gravity. So this could happen if something is being pulled at an angle where a portion of the force is applied upwards. This could happen if something is being pulled up but not being pulled off the floor. So if you imagine a box with some sort of balloons kind of pulling up on it a little bit, there is no motion in the vertical direction, so the Fg has to be equal to the applied force of, say, the balloons, or the upwards applied force, and any remaining force has to be the normal force. Any remaining normal force has to equal, has to sum to the applied force so that it equals the force of gravity. So that's something else to consider. You may not see a lot of those problems, but they will come up as you take more physics courses.